Hello, everybody. This is Mr. 13 Things. Still harping on those 13 things, which then beget other things. So what we're going to talk about today is a little bit more about the inconvenient angle of pi over 12. Inconvenient angle, which is pi over 12, or if you want, 15 degrees. And we'll talk about why it's really not that inconvenient. What is it? It is 1 hour's rotation of the Earth. About 1 hour's rotation of the Earth. Or the Earth. The Earth. And as always, we're going to talk about that, talking and starting with the unit circle, which I can never draw correctly, but I'm going to continue to try. That one's not bad. All right, so remember, always the radius equals 1, the diameter equals 2, the area equals pi, and the angle, if you want to think about that as an angle, equals 2 pi. Always, 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 as you draw this up, and then you remember that all circles are the unit circle made larger or smaller. What I'm going to do here is I'm going to go ahead and try to draw, basically, poorly, if you would, the square that encloses this. And if you look at that square, okay, that is a 2 by 2 square. And that, of course, is then an area. Area equals 4. So 4 is more than pi. Now, angles of the square doesn't necessarily make much sense. We won't really talk about that. But you can talk about the circumference actually is the same. So I can go ahead and write here the circumference equals 2 pi, right? Because it's, and this is the circumference, or the perimeter, if you would, the circumference per perimeter equals 2, 4, 6, 8. And so you start to see some ratios there, but very often you're going to get even more confused. You can figure out the area is 8, and really the circumference will come. We really want to think more about the angle and the area when we start talking about this. All right, so the inconvenient angle. Remember, the inconvenient angle was an angle of 15 degrees, pi over 12. And the cosine of that was larger than the sine, and it was the square root of 6 plus the square root of 2 all over 4. And the sine of that angle was the square root of 6 minus the square root of 2 over 4. But what the heck is this? What is the square root of 6? What is the square root of 2? Divided by 4, I guess you can see it. So this is the same as, if you would, the square root of 6 divided by 4 and the square root of 2 divided by 4. Well, let's remember now that you do know what the square root of 2 looks like in terms of distance first. So I'm going to go ahead and cut that up. And remember that I'm going to do an edit, undo. Remember that that distance there is the square root of 2. So that's the, and I'm going to do an edit, undo, see if I can do some colors, edit, undo, and I'm going to try to change my color here, and we'll make the square root of 2 to be blue. Nafu. Alright, so that is the square root of 2 in terms of length. Now, what about the square root of 6 in terms of length? Well, you're not going to be able to really easily construct that on here, at least as far as I can say. So let's now compare, let's figure out the square root of 2 in area is going to be basically this length, which is the square root of 2 times 1, and we'll try to guess it in here. You could tip that up if you would. This would be tipped up. I'm going to go ahead and draw a circle here. Right, so it's a little bit more. And then, so this would be the square root of 2, a little bit more here. And then it would be that area there. So the area would be, that would be the square root of 2. What have you done? You've actually taken that little hypotenuse and you've turned it to be vertical. And I've done that wrong. This is the square root of 2. I'm going to do edit undo. Edit undo, edit undo, edit undo, edit undo. See how much this will go? Because we have to remember when we do this, edit undo, edit undo, edit undo, edit undo, edit undo, edit undo, which is the great thing about using short lines. This is the square root of 2, this is 1, and so this area would be the square root of 2. Right? So that area is the square root of 2. Of course, later on you have to divide it by 4. So let's figure out now what is the, change the colors now. What does the square root of 6 look like? Change it to red for that, close. Let's remember, let's go back to the square root of 2. And if in fact we could make this side the square root of 3, we would be square root of 3 times the square root of 2 equals the square root of 6. So we would get an area that is the square root of 6, which is greater than the square root of 2. In other words, this length here is going to be longer, and here's how, if you remember, we got that length. We go ahead, we divide this in half, and this in half, and we take this line out, change colors again to red. Take that line through here, through that 60-degree point. That becomes the square root of 3. And you rotate that to 90 degrees. And now you have the square root of 2 times the square root of 3. That becomes the square root of 6. So in effect, what you have to do is add these two areas together, divide by 4, and you get what is the cosine. And if you subtract those two areas and divide by 4, you get the sine. Once again, we're doing this purely so that you start to own the kind of relationships you can get out of here in both angles and areas. That is so that when we tie forward to something called the unit hyperbola and get area analogies, that we don't really have a problem with that. So the square root of 2, how do we go about doing it? I'm going to go ahead and see if I can go ahead and do this whole thing. Try it again. I'll just take out to here. Edit. Cut. It would be great to scale that. Remember, here's how you get the square root of 2 in terms of an area. You go ahead and draw the unit circle. Do a better job. You've split it in half. You take that length there, and then you just basically take an arc, right? That length there is going to be a little bit larger. You now take this length times 1, and that becomes the square root of 2. And if you divide that in half, you'd have the square root of 2 over 2. Divide that in half again, you'd have the square root of 4. So you can do that with basic constructions in terms of bisecting lines. And we'll see if we can do that when we have one of the neat tools that exist on the smartboard that we do not have at the moment in terms of something called a compass. Compass, stick your friend, not get lost in the woods compass. All right, now that is the square root of 2. What was the square root of 6? Again, draw that unit circle. I'll go ahead and do the first one first. Remember, we divide this in half, divide this in half, take that line, extend it through 60 degrees. That becomes the square root of 3. We have this line here. That's the square root of 2. You just have to kind of rotate that to 90 degrees. And then you have the square root of 3. And so that area there is the square root of 6. Area-wise. Remember, you can compare lengths, you can compare angles, you can compare areas. And they generally don't equate for the same thing, though. In a unit circle, you know that the area subtended by an angle pi over 2, the area, if the angle is pi over 2, the area equals pi over 4. Because remember, the area of the unit circle is pi and the angle is 2 pi, so you divide the angle in half to get the area. Thanks for listening. That's a bit muddled up, but we're going to see what we can do about animating that so we can tie this square root of 6 Remember the 2, 4, 6 pattern, 2, 4, 6 pattern, and the logic to plus or minus. You really shouldn't need this, but it's always good to see the areas.